Did you know that the induction motor, invented in the 19th century, powers more than half of all electrical energy consumption? Astonishing, isn't it? Now, have you ever wondered how induction motors work? Why they're so vital in our everyday lives? Induction motors, my friends, are the unsung heroes of our modern world. They hum quietly in the background, everything from the fridge that keeps your food fresh to the drill that helps build skyscrapers. Now let's get to the heart of the matter, the magic word, induction. Induction is the process by which electrical current is generated in a circuit by changing a magnetic field. This is the fundamental principle that powers these motors. No direct electrical connection is needed, making them durable and efficient. They're like the magicians of the mechanical world, converting electrical energy into motion almost as if by magic. We've only just scratched the surface of this fascinating subject. There's a whole lot more to discover about these silent powerhouses. So buckle up, and let's delve deeper into the fascinating world of these silent powerhouses. To understand induction motors, we first need to comprehend the principle of electromagnetic induction. This phenomenon is a bit like a magic trick. Imagine a magician who we'll think of as our magnetic field. Now picture a coin, which represents our electric current. The magician doesn't touch the coin, but with a wave of his wand, he makes it move. This is similar to how electromagnetic induction works. The magnetic field, our magician, creates a force that causes the electric current, our coin, to flow. The remarkable part is, they never have to touch. The magnetic field can induce or cause an electric current in a conductor just by being in its vicinity. It's like the coin moving at the mere wave of the magician's wand. This invisible, touchless interaction is the crux of how induction motors work. That's the magic of induction, the foundation of our induction motor. At the heart of an induction motor lies a key component called the rotor. Now you might be wondering, what exactly is the rotor and what does it do? Well, let's imagine a runner on a racetrack. In this scenario, our runner is the rotor, and the racetrack is the magnetic field. The runner, or the rotor, is strategically placed within the magnetic field. When electricity is applied, it creates a magnetic field around the rotor. This magnetic field is like the starting gun at a race. It propels our runner forward. The rotor starts to spin following the magnetic field, just like a runner follows the track. It's a chase of sorts, with the rotor always trying to catch up to the magnetic field, but never quite getting there. This continuous movement, this perpetual chase, is what creates the mechanical power needed to drive the motor. This runner, our rotor, is what drives the motor. So how does all this come together to make an induction motor work? Let's weave the threads together. Imagine our magician, the magnetic field, waving his wand, the stator. As he waves, he creates a spell, energizing the air around him. This spell is the electrical current, and it's this spell that our runner, the rotor, can't resist. Just like a runner can't resist the finish line, the rotor can't resist the magnetic pull. The magnetic field induces or creates a current in the rotor. This current then reacts with the magnetic field, causing the rotor to move. It's like a dance, a push and pull between the magnetic field and the rotor. And once the rotor starts moving, the motor is in action. The rotor spins, the motor runs, and the magic happens. This magic is what powers your blender, your air conditioner, your car, and so much more. And that's how an induction motor powers your everyday life, from your washing machine to the elevator in your office building. So what are the key takeaways about induction motors? Well, let's wind the clock back a bit. The magic of induction motors lies in the phenomenon of induction itself, where a changing magnetic field in the stator, the stationary outer part, induces a current in the rotor, the spinning inner part. Imagine the rotor as a hamster in a wheel, motivated to move by the stator's magnetic field, like a carrot dangled just out of reach. The hamster chases the carrot, and voila, the wheel spins, and we have motion. That's exactly what happens in an induction motor. These motors are everywhere, silently powering our daily lives. They're in your blender, making your morning smoothie, in the elevator taking you to your office, in the electric car you drive. They're the invisible magicians behind the curtain, making our world go round. Now, when you use your blender or take an elevator ride, you'll know there's a bit of magic happening thanks to induction motors. Thank you, fantastic viewers, for being a part of the Fix Flare Tech community. Your support means the world to us. Stay tuned for our next video where we'll unravel another fascinating tech topic. Until then, keep exploring, keep learning, and I'll catch you in the next one. This is MQ Joshi, signing off from Fix Flare Tech. See you soon.